Thanks for having me here. Is this on right? Is that good? Okay. Today I'm going to talk to you about implementing a visual CSS testing framework using automatic screenshot comparison to catch style regressions. My name is Jessica on the internet and Jessica in real life, and I work at a company called Bugsnag here in San Francisco. Bugsnag is an exception monitoring tool. I'm a software engineer there, working primarily in Ruby and JavaScript, but our stack includes lots of languages including Node and Go. We're currently hiring, so please get in touch if you're interested in working at a super small company for developer tools. So back to this whole implementing a visual CSS testing framework thing. What am I even talking about? Well, at Bugsnag, we decided we wanted a way to automatically take 2 screenshots of our website at different times in our app. For example, since we use Git, let's say we had a feature branch that we just pushed a commit to. We'd want to take a screenshot of what our home page looks like on that branch and a screenshot of how our home page looks on production or what's currently running on master. With those screenshots, we'd want to spot those differences and produce some sort of diff image that highlighted the differences. Why would we want to do this, you ask? Well, as we all know, writing, reading, and code reviewing CSS can be pretty intense, and even more intense to refactor. At Bugsnag, we decided to do a huge organizational and code style refactor of our CSS, and we wanted a way to test that our site looked the same despite changing all of the code. Unfortunately, as you can tell, that didn't really always work out for us. We went through many iterations of refactoring, and we realized we needed a tool to help us out and test our pages automatically. So we went on a hunt for a way to test our CSS. We wanted to know if there was a tool already built that did what we wanted, without knowing exactly what it is that we did want. We first stumbled upon one of Facebook's open source libraries, Huxley. In Huxley's README, it says, watches you browse, takes screenshots, tells you when they change, which sounds amazing. It's exactly what we wanted. But I noticed it hadn't been updated in over a year, which wasn't promising, but I decided to give it a shot anyway. After a good while of fiddling around with Huxley, it ended up being a little bit too buggy for us, although I did hear somebody talking about it did work for them, so I'm happy. Yes. But for us, it would have random failures, randomly wouldn't take screenshots, and I started realizing it wasn't exactly what I was looking for in a CSS testing tool anyway. I kept looking, and it turns out there are a lot of frameworks that do some sort of CSS testing. They all work in different ways. Some take screenshots, some aren't even visual. I definitely recommend checking some of these out and seeing if they fit what you're doing in your apps before trying to build your own. But I really started thinking about it. What was I looking for in a CSS testing framework? What would fit the way Bugsnag is built best? I decided I wanted a visual way to test my CSS with screenshots rather than writing out tests describing the visuals. This is where I need a disclaimer. At Bugsnag, our web dashboard is written in Rails. This, mixed with the fact I wanted the test to take screenshots, affected my decisions in what frameworks I wanted to use. We also use Git for our source control at Bugsnag, and we use it the GitHub way. What that means is we have a master branch, which is always deployable and production ready, or it should be. And whenever we want to create a feature, we branch off master until it's ready, and then we merge it back into master. Considering the tools we had at our disposal, and after taking a look at some of the screenshot libraries, their source codes, I realized that there actually wasn't that much code going on in them, so I decided, why not? I'm going to write one myself, which is always a bad idea. I came up with a process of how I thought I wanted my tests to work. Number 1, I wanted a way to somehow automatically visit pages of our site. So the test would, in an actual browser, hit each page of our site on a local server. Once the test visited the page, I wanted the test to take a screenshot of that page. The important bit for the screenshot is that I'd want it to take a screenshot of the entire page, not just the current viewport of the browser. For example, if a change happened below the fold of our site, but we weren't taking full page screenshots, we wouldn't be able to capture the diff down there. Next, I need somewhere to store these screenshots, and I need a way to upload and download these screenshots from that storage area. So using Git, every time I made a push to a branch, I'd upload a screenshot of the current state of each page, including our master branch. And if I had a screenshot already uploaded to our storage area from our master branch, I'd need a way to upload my current features branch to that storage area and download my already uploaded master screenshot from that storage area. I'd then need a way to make a diff of my screenshots. I'd want a diff between a screenshot I took on master, downloaded from our storage area, and the newest screenshot I took on my feature branch. So if I have the previous screenshot I took, which would be the current commit on master, versus my branch's screenshot, I'd need a way to mark the differences between those two screenshots visually, so in here it's the header. Finally, after I have diffs for all my screenshots, I need a way to view the diffs. Even though I'll have a place to upload them, I need an accessible way for everyone on the project to view the diff screenshots, depending on the commit. So now we have a plan. We can start building out our framework around these things that we need. We need a way to write some specs that will automatically run after each push. So we decided to use rspec. rspec is a testing tool for the Ruby programming language. We already had rspec for our tests in our Rails app, so writing these tests with rspec made sense. We wanted to be able to write specs that look just like this, where we'd be able to navigate to a local URL and save a screenshot of that page. We also wanted these tests to be separate from our main tests. We pulled out these visual specs into their own rspec tag. That way, these specs wouldn't run with our main specs when we were running the suite locally unless we explicitly asked it to. This also made it so we could break out our specs on our CI. We wanted our visual specs to be separate for a few reasons. Number one, our local build speed. If our local tests were bogged down by waiting for our visual specs, that would become a huge issue. By having them broken out, we could iterate on our main specs faster and be able to push out more often. Number two is speed with our CI tests. We wanted our main specs to still be fast on our CI so that we could merge non-visual pull requests without waiting for our visual specs to finish. CI, or continuous integration, is a way for us to automatically run our test suite when we push things to GitHub. And after our specs run on our CI, we're able to see if our build is passing or not. I also learned that GitHub just released a new feature where you can split out your builds, so thanks GitHub. So now we'll be able to split out our visual specs from our main specs here, and so we can quickly see which build is passing or failing, or still running, without the builds being combined. At Bugsnag, we use BuildBox for our CI. BuildBox allows us to add steps to our tests. That way we can run our main specs first, apart from our visual specs. And when they're separate, our visual specs don't slow down our main specs, and we can merge non-visual pull requests without waiting for our visual specs to finish. Next, we needed a way to visit pages and take screenshots with our rspec tests. For that, we decided to use Selenium. Selenium is a tool for automating browsers for testing purposes. We would need to use specifically their WebDriver API. This would allow us to drive a browser natively on a local or remote machine, and more specifically, this provides an API between us and the browser. To use Selenium, we need to use a service like Sauce Labs or BrowserStack. Since we are using a CI, it doesn't just have browsers built in on the server. We'd either have to set up our own virtual machines for these browsers or use one of these services. So we ended up trying BrowserStack. Before our visual tests, we'd need to start our proxy to BrowserStack and a forked Rails server. And then we need to make an instance of our Selenium WebDriver. And then, of course, after all of our tests, we would terminate these services. We also had to allow webmock. Webmock is a library for stubbing and setting expectations on HTTP requests in Ruby. This is to run real web requests in order to use our local servers and upload our screenshots. To get our BrowserStack proxy running, we would just spawn a new BrowserStack process and terminate the process using its assigned PID. And to get our Rails server running, we would just spin up a new Rails process at port 3000, unless one was currently running, and terminate it the same way as our BrowserStack process. To set up our Selenium WebDriver, we just have to pass it the capabilities we wanted, like the browser information, and a URL to hit, which is pointed at our BrowserStack. Setting up our Selenium driver was easy, but when we were setting it up, we did learn some interesting things about taking screenshots with different browsers. With our WebDriver, we wanted to hit pages in a real browser and be able to take screenshots of the full page, not just the current viewport. Unfortunately, this feature only worked in Firefox, which was not ideal. Since Internet Explorer and Chrome didn't work, we couldn't really transform this framework we were making to be used for browser compatibility or anything like that. Although this wasn't ideal, for our purposes right now as a refactoring tool, Firefox worked fine. After running our tests for static pages such as our home page, we quickly realized that we'd have an issue with the dynamic data on our dashboard. With dynamic data, you can get false positive diffs because data can change between the viewing times. To combat this, we set up fixture data for our RSpec tests and manually adjusted any other data not covered by fixtures using Selenium's JavaScript support so that we don't get a false positive diff. Okay, now we have our test taking screenshots. We need to figure out a way to make a diff between two of our screenshots. ImageMagick worked perfectly for this. Despite having literally one of the worst sites I've ever seen, ImageMagick did exactly what we needed. ImageMagick is a tool to convert, edit, and compare images. ImageMagick has a command line compare tool that, with various options enabled, allows us to shell out and produce diff screenshots based on two other screenshots. For example, when we make a simple change to the header, ImageMagick would spot those differences and produce a screenshot like that. ImageMagick has a lot of options you can pass to its compare tool, and we take advantage of a few of these options in order to make it work. Let's go back to those options we used for a second and go over how they actually work with what we're doing. ImageMagick's compare tool, from their website, mathematically and visually annotates the differences between an image and its reconstruction, or in my terms, takes two images and provides a diff. Compare lets you provide a metric that outputs to a standard error a measure of the differences between images according to a type of given metric. Here we're using PAE, where PAE stands for peak absolute. We can use the peak absolute to find the size of the fuzz factor needed to make all pixels similar. So if we had screenshot 1 and screenshot 2 that were pretty different, it would end up producing a diff like this. And our peak absolute measurement would be outputted as needing a huge fuzz factor to make all pixels similar. The fuzz factor can be important in case we want to ignore pixels which only change by a slight amount. We might want to ignore small changes in case of false positives. For example, I've had false positives before because gradients rendered slightly differently between two images. We don't actually use this output right now, but it would be important if you wanted to make an assertion in your tests meaningful, like actually have a failure if a diff was produced. We didn't end up doing that because it doesn't necessarily mean something's wrong if a diff is produced. It just means something's changed. A few times when we were running our specs, we noticed that diffs weren't even being produced. We took a look at the screenshots and realized that they were different heights or sizes for some reason. Like if we made a change that accidentally removed the footer. ImageMagick wouldn't let us do a default compare on these images, so we had to use a sub-image search. Sub-image searching is required to have compare search for the best match location of a small image within a larger image. This option will produce two different images, or two frames is what they call them. The first is the diff image, which is the one we're going to be using, and the second would be the match score image. The match score image isn't really important to us, but it's an image that's a smaller image containing a pixel for every possible position of the top left corner of the given sub-image. The search will try to compare the sub-image at every possible location in the larger image. This can make sub-image searching very slow. As you could guess, the smaller the sub-image is, the faster this search is. That being said, this option doesn't take effect unless you have two images that are different sizes. This doesn't happen very often to us, so the amount it slows down our visual specs on CI isn't really meaningful to us, especially since those specs aren't tied to our main specs. Another fun thing we ran into was sometimes our screenshots were completely different. Like, completely different. And ImageMagick was not into it. In fact, it just wouldn't even give us a diff because the images were so different. We found an option called the dissimilarity threshold, which I find kind of weird. This threshold determined how different two images could be in order to diff them. It defaulted to 0.2, so I just made it 1, and it seemed to do the trick. The only caveat, as you might have guessed, is doing diffs on completely different images can slow down your test by a lot. Like our previous issue with sub-image searching, this doesn't seem to happen much, and since the tests are separate from our main specs, we aren't too worried about it. Last three arguments aren't very exciting, just where our current screenshot is located, where our master screenshot is located, and where we want the diff to save to. Okay, now that we're done with that stuff, now that we had our screenshots and our diffs, we needed somewhere to actually throw the screenshots online and be able to grab them back out with our Rails app. So we decided to use AWS. AWS, or Amazon Web Services, offers cloud storage and has a Ruby API. So we'll store and retrieve our screenshots from one of their buckets. We ended up using a naming pattern of commit-sha, area of site, page name, and image type. So for an example, we could have a commit-sha of A1, A1, A1A, very realistic, I know, where we're on our marketing part of our site on the index page, and we're uploading the diff for that page. The image types could be the current screenshot we took, the master screenshot we downloaded from S3, or the diff we made of the 2 screenshots. Viewing the screenshots from an Amazon bucket was far less than ideal, so we decided to set up our own custom viewing page in our admin dashboard. We created a page that listed out our current branches with our last 3 commits, and when you would click through, it would show you, by area, all of your screenshots and diffs, which is our end goal. We did it. However, our tool is not perfect right now. It's certainly better than what we had, which was nothing, but right now, all of our tests pass whether or not there's a diff. They'll only fail if there's an issue executing the test. It could be interesting to make our assertions mean something, like fail if there's a diff. We need to think more about that because a diff, like I said earlier, doesn't necessarily mean a failure to us. In the future, it might also be nice to account for 0% diffs. So maybe we shouldn't upload a diff image at all if there's no diff between the images. This could save us space on our AWS bucket, as well as speed up our tests because we're trying to upload fewer screenshots. And it would make our admin dashboard less noisy. We also think it would be nice to automatically link these to a GitHub pull request. So when a diff is created, maybe automatically attach it onto its relevant pull request. This one's a little tricky because maybe we don't want to create that much noise every time we push, but it's an idea, something we need to think about. Another thing is that we currently only diff between our current commit on a branch and versus our most recent commit on master. So when we push a new commit to our branch, it'll diff versus the last thing that we push to master. This way, we know what's changed between the feature I'm working on and what's currently running in production. It would be nice if we could diff on master with the current most recent commit and its previous commit. So that way, in case you push a visual change directly to master, which don't do that, you could still see a diff for it. It would also be nice to see a diff between the previous commit on the current branch as well. Like if you pushed a commit to your branch that changes some stuff visually, you might want to see a diff between those two, regardless of what's happening on master. I'd also really love to get this hooked up to more browsers. That would really enable us to make this into a backwards compatibility tool, as well as an automatic browser comparison to make sure things aren't messed up in IE. Thanks, that's all I have. And feel free to ask me questions after if you're interested.